Namaste and good morning to everyone. I'm Krishna Bhargavi, working as Assistant Professor in the Department of CSE GRIET. In this video, we'll be discussing about the different relationships available in ER diagrams and also different constraints applicable on the ER diagrams. The learning objectives of this session are to identify different types of degrees of relationships, the purpose of a weak entity set, and also what are the different constraints imposed on ER diagrams. So what do you mean by a relationship? We already knew that ER diagram mean entity relationship diagram. So the entities are the real world objects. Being real world objects, we usually communicate to one another. So the communication between different entities is represented in the form of a relationship. So it is the association among two or more entities. Usually these are the action verbs, like the faculty works in a department. Works in is a relationship. The student belongs to a department. Belongs to is a relationship. Faculty teaches the student. Teaches is another relationship. So relationships are usually the action verbs. A set of similar relationships is said to be the relationship set. And for some of the relationships, there may be some attributes describing the relationships. So such attributes are called as descriptive attributes. And the pictorial representation for a relationship is represented with a rhombus. So here we are representing the relationship with rhombus, and as we know that ER models must have a label associated with every representation. So here this works in is the label that is associated with this relationship. As an example, here we are considering employees is an entity. These set of employees are identified by the attributes the social security number SSN, which could be the key that uniquely identifies and distinguishes one employee from the other employee. The second attribute is name, and the next one is whatever salary or that belongs to this employee. Then departments is another entity where we have department ID, which is again the key attribute, department name, and budget allocated to each department. So what does the relationship that exists between the employees and the departments? The employees works in departments. So here the relationship that we are considering is works in relationship. And for this relationship, there could be an attribute describing this relationship. What could be that attribute? Since. So from which date this employee is working in this department can be depicted in this format. So here since is called as the descriptive attribute which describes the tenure from which an employee is working in a department. Then we have the degree of relationship. This is nothing but the number of entities that are participating in a relationship. So here we have different types of degrees of relationship. The first one is called as unary relationship, where only one entity participates in the relationship. Second one is binary relationship. Here we have two entities participating in the relationship. Third one is ternary relationship, where we have three entities participating in the relationship. Quaternary relationship, where four entities participate in the relationship. And we have n-ary relationship, where n entities can be participating in the relationship. So here as an example we are considering the first one here is the unary relationship. So here faculty is an entity and reports to is a unary relationship, because being a faculty who is a subordinate may be reporting to the supervisor, but both the supervisor and subordinate both are faculty members only. So their properties are same. So here these supervisor and subordinate who are faculty members. So here we are making use of a unary relationship to represent this. And supervisor and subordinate are called as role indicators, and using role indicators in a unary relationship is mandatory. The second one here we are representing is a ternary relationship where employees are working in the departments at certain locations. So if we consider an employee, he is working in the HR department located at Bangalore. There could be some employees working in the development department. They may be locating at Chennai. So here, in order to include the locations where the employees are working, we are considering this ternary relationship. But please keep in mind, in ER diagrams, these support only the binary relationships. So, and sometimes the unary relationships too. So in case if there are any ternary relationships, how to handle them? So the ternary relationships are converted into either individual binary relationships or into aggregations. So here we are taking an example for the binary relationship. So faculty works in the department. So this is the binary relationship. So our question is, why does ER diagrams will only handle binary relationship? Because when these diagrams are translated into tables, the table can be connected to another table using the common columns. And at a time, you can have only the referential integrity constraint to be specified between two tables only. So because of this reason, we will have only binary relationships supported by ER diagrams. Then we do have different constraints to be specified on these ER diagrams. These are specifically divided into structural, covering and overlap constraints. The second and third constraints we will be covering in the next video, where we will discuss about the extended ER features. The structural constraints we will cover in the next slides. So these are again categorized into cardinality ratio, which we also call as mapping cardinality, and the second one is participation constraints. So coming to cardinality ratio, we also call this to be the mapping cardinality, and the cardinality ratio expresses the number of entities to which another entity can be associated via a relationship set R. So in this example, I have removed the relationship set R only for our understanding sake, but there must be a rhombus R connecting these A and B entities. So depending upon the cardinality ratio, the relationships again are classified into 4. So the cardinality ratios of relationship sets can be of 4 types: 1-to-1, 1-to-many, many-to-1 and many-to-many. So in a 1-to-1 relationship, considering the two entity sets A and B, at most one entity from A can participate in the relationship set R in the entity set B. But if it is 1-to-many, at most one entity in A can participate in n entities in the B entity set. Many-to-one, the reverse of 1-to-many. So n number of entities from A can participate in the relationship set R with at most one entity from the entity set B. Then many-to-many, any number of entities from A can participate in the relationship set R in the entity set B. So these are the 4 cardinality ratios that are available with the relationship set. Then moving further, considering the participation constraints. So here, how the entities are participating, whether they are totally participating or they are only partially participating, is identified by making use of the participation constraints. So here we will say that a participation of entity is total if every entity in E participates in at least one relationship in R, and a participation is said to be partial if only some of the entities in E participates in the relationship set R. So here is an example that we are considering. Students enrolling for the courses. So it is mandatory for every student to participate in one course or the other course. So all the students are participating in the courses. So that's why students are totally participating. We represent that using double line. But from the courses, and if you observe, all courses need not be opted by all the students. So only some of the courses will be participating in this enrolled relationship. So that is why the course is partially participating in enrolled in relationship. Considering here, the cardinality ratio for the student entity in this relationship enrolled in will be minimum 1 because every student must participate, maximum will be m. But for course which is a partially participating in the enrolled relationship, the minimum cardinality ratio will be 0 because some courses need not be opted, but the maximum cardinality will be n. So the minimum cardinality ratio for total participation will be 1. For partial participation, it will be 0. So after understanding these participation constraints, we will classify the entities into strong entity and weak entity. As we know that there will be a key attribute which identifies the entity uniquely, the strong entity will have a key attribute to be identified. But weak entities will not have any key attribute, so they will be depending upon the key attribute of the strong entity. So for a weak entity, it must always have a one-to-many relationship with the strong entity. As well, it must be totally participating in the strong entity. And the set of attributes on the weak entity set that is useful for identifying the weak entity in conjunction with the strong entity, we call them to be the partial keys. So let us go up with an example here. So employee is a strong entity because it is having the key attribute employee ID. But the employee may be having multiple dependents. So dependence here is a weak entity because dependent will not be given a dependent ID. So here we are representing the weak entity with double rectangles. So how to identify a dependent? A dependent will have a name, but to identify a dependent, we require the employee ID to whom does this dependent belong to. So here the conjunction of employee ID with the name must be available. So here if you observe, the dependent is depending upon this identifying owner. So the dependents must participate totally in this relationship. The identifying relationship is represented using double rhombus, and the partial key is also called as discriminator attribute, which is represented using an underline, dashed line. So here a weak entity strongly depends upon an identifying owner. So with this, I am concluding today's session. Hopefully that you understood the different types of relationships based on the degree, the cardinality ratio, the participation constraints, and the types of entities classified as strong and weak entities. Thank you.